Hello everyone. Today we are talking about object oriented programming. We aren't just learning how to write the lines of code, we are learning how to build digital worlds. Let's dive in. Before we define what is object oriented programming, we need to understand a fancy word that is paradigm. Don't let the term intimidate you. A paradigm is simply a style or philosophy, or how we organize our thoughts to solve a problem. In programming, we have two main styles you need to know. Procedural. Think of this as a recipe. You do step 1, then do step 2, and then do step 3. It's the linear and straightforward method. Second one is the object oriented. Think of this as a city. You have buildings, cars, and people. Each is a separate unit that interacts with each other. As the software evolved, we realized that the city model is much more powerful than the recipe model. So, why did we move away from procedural style? Because procedural code has a major flaw: data vulnerability. In procedural code, your data is often global. Imagine a blank bank where anyone can walk in and change off any account. That's a nightmare. It leads to spaghetti code, a tangled mess where changing one small thing breaks the entire system. It's hard to scale and even harder to reuse. OOP was created to fix this by mapping our code to the way the real world actually works. The best way to understand an object is to look at the one in your pocket, your smartphone. An object in object oriented programming has two things. One is the state, that is the data, what the phone is, its battery level, the model, the color. Second is the behavior. This is the action, what the phone does. Placing a call, sending a text, or clicking a photo. In object oriented programming, we wrap the state and the behavior into a single unit. You don't need to know the complex circuitry inside the phone to use it. You just use the behaviors. You will hear these two terms constantly: classes and object. Here is how we keep it straightforward. A class is a blueprint. If you look at an architectural drawing of a house, you can't live in it. It's just a logical template on paper. It takes no memory. An object is the physical entity, it is the actual house built from that blueprint. It occupies real space in your computer's RAM. Remember, you can use a single blueprint to create thousands of unique houses. That is the object. That is the power of classes. Now let's talk about the four pillars of object oriented programming. The first one is encapsulation. Think of a medicinal capsule. The internal medicine is hidden and protected by the outer shells. In Java, we wrap the data and the method inside a class which acts as a shell. This is called data shielding. It ensures that no one can accidentally mess with our internal data from the outside. It's all about security. The second pillar is abstraction, which is all about managing complexity. Think of a car dashboard. To drive, you will need to see the steering wheels, the brakes, and the speedometer. You don't need to see the fuel injection process or the pistons moving. The complex logic is hidden. In object oriented programming, abstraction allows us to use only what is needed to be seen, making the system much easier to interact with. The third pillar is inheritance. This is the secret for code reusability. In the real world, a child inherits the traits from their parents. A child class inherits properties from a parent class. For example, a sports car is type of vehicle. It inherits the basic engine and wheel logic automatically. This saves us from rewriting the code over and over again. The final pillar is polymorphism, which literally means many forms. Think of it as a prism reflecting light. One beam of light goes in, but many colors come out. In programming, it means one action can perform differently depending on who is doing what. If I give an example, think I'm giving a command speak. A dog will woof, but a cat will meow. The command is the same, but the forms of response is different. Why do we see this in action? Java is the most famous and is strictly object oriented based and used massive for enterprise systems. C++ is hybrid. It lets you do both procedural and object oriented programming. Python is incredibly flexible and is the go to for data science and AI. Understanding OOPS in Java makes it incredibly easy for you to pick up any of these other languages later. To wrap up, object oriented programming is not just code, it is an architecture for reality. It makes our software secure, reusable, and easy to grow. Thank you for your attention today. In our next session, we are going to dive deep into actually writing our first classes and object. I will see you then.